We're continuing our discussion on finding domain questions. Previously, we looked at 6 functions. Today, we are looking at 2 complicated problems that require more steps and more techniques. On the left is a fractional function with a linear on top and a square root on bottom. And on the right is a square root function in which the radicand is a rational function with a quadrant on top and a linear on bottom. Okay, just a quick review here. Remember, when you're asked to find the domain of a function, what it really means is you're looking for x values for which the function will give you a value back. So what x value will work, giving you value back, and what x values will not work, meaning it doesn't give you a value back or it gives you undefinedness. In short, x values that work are part of your domain. When x values do not work, you toss them out of your domain. So in Algebra 2, when you come across these problems with finding domain, there's really just 2 main things to watch out for when you're dealing with a fraction or when you're dealing with a square root function or some other even root function. Okay, so here on the left side, if you have a fraction involved and there's a 0 in the denominator, we learned in the past that this is not a number, it's undefined. It has no meaning to it. Okay, so that's one bad situation. On the right hand side, you have a square root of a negative number. And when you try to take square root of a negative number, you also have undefined. You can take the square root of positive numbers and 0, but not negative numbers. So in both cases, having those things happen would cause the output to be undefined. So these are the things that you really have to watch out for when you're asked to find domain of a function. On the other hand, if you have a 0 on the top of a fraction, then that's okay, because 0 over anything always equals 0. So, and don't forget, 0 is a defined number, so there's no undefinedness involved here. So that's fine. And if you look on the right hand side there, you can also take the square root of a 0, because 0 times 0 is 0. So these situations will not be a problem. So you definitely want to include these the things that cause the situation like this to be part of your domain. The thing that's on the left here is a very common mistake on quiz and tests. Typically, people want to talk about what caused the top to equal 0 as part of their solution to say, things that people should be tossing out of the domain. But do not do that, okay? Leave it alone. Whenever you have a 0 on top, it's okay. Leave it alone. So let's look at the first problem here on the left side. On the domain of this thing here, where we got 6x plus 3 on top and the square root of 3 minus 2x on bottom. So here I have copied onto my whiteboard the function 6x plus 3 on top, square root of 3 minus 2x. So let's go back to the basic questions. What do we have to watch out for? Because the things that do not work, we toss them out of the domain. Things that do work are part of the domain. So we got a fraction here. So in a fraction, is it okay to have 0 on top? Is it okay to have 0 on bottom? These are the kind of questions you should be asking whenever you see a problem like this. Okay, so if you look at the top part here, 6x plus 3. If you plug a number into x, notice you will always get a number back. Okay, there's no way the top will ever give you undefinedness. And the top can give you 0, but remember, we don't care if they give you a 0. It's okay to have 0 on top. It just makes the expression overall 0 also, which is defined. So we want to look at the bottom part next. Okay, what do we have to watch out for there? So here you got a radical and you got a radicand, basically the 3 minus 2x part there. So what do we have to watch out for? What do we need? We need the radicand part, which is the 3 minus 2x, to be greater than or equal to 0, right? Well, not quite. Remember, it's on the bottom, so you can't have it equal 0 either. So we make it strictly greater than 0. Okay, and then now solve for that expression, solve for that inequality. You will, need to move the 2x to the other side, separate from your constant, and then divide both sides by 2, and so 3/2 is greater than x, or if you prefer going the other direction, x is less than 3/2. Okay, so our final answer is domain is the set of all x values such that x is less than 3/2, which is 1.5. Okay, let's quickly check our answers. So, basically you want to test points, numbers that's greater than 1.5, test a number that's exactly 1.5, and test numbers that's less than 1.5, because that's basically the boundary of your inequality. So if you plug in 3/2, which is right at the boundary, then notice that will cause the denominator equal 0, because in effect you're taking the square root of the 0, which is 0. So that's a problem there. That causes undefinedness. Okay? Now let's test numbers greater than and less than 3/2. So in the second situation, if you plug in 1, which is less than 3/2, then you on the bottom you have the square root of 3 minus 2, or just square root of 1. So the bottom equals 1. And that's not undefinedness. Okay? You've got a top number over the 1 number, so that's still a number. In the third situation, if you plug in 2 into x, then you have 3 minus 4, and then you'll be taking the square root of -1, and that's what causes undefinedness. So notice our solution does work, and we checked it with these 3 different numbers that's greater than, equal to, and less than 3/2. Okay, so let's take a look at our second problem, where we have the radical completely umbrella entire rational function. How does that make the problem harder? Okay, copy it over to the whiteboard. We ask, find the domain of f of x equals the square root of this rational function. If you focus on the bottom first, we know that 6x plus 3 should not equal 0, because that will cause undefinedness. And, some people might want to look at the top also and go, well, this is a square root, so maybe this x squared minus 4 should be greater than 0. Well, neither one of these are correct first step, because this x squared minus 4 over 6x plus 3 is actually one whole piece. You need to treat that as one piece of information. You want to treat that as your overall radicand. So think back what we said before. You want the radicand of any square root function to be always greater than or equal to 0, because it cannot be negative. So with that mindset, rewrite this need statement one more time, except this time write need, the stuff that's highlighted here on the far right. We need that radicand, x squared minus 4 all over 6x plus 3 be greater than or equal to 0. This is the right approach. Rather than treat those individually, you're actually treating this as the radicand. Okay, so now this is something we're familiar with. How do you solve for this? Well, this is complicated because you have a top and a bottom, so this is where the sign chart comes in. But the first thing you must do is you must factor your rational function as much as you can. Okay, obviously the top factors, because of the difference of squares, so it factors to x plus 2 times x minus 2. The bottom also factors. There's a GCF of 3, and if you factor that 3 out, the bottom is now 3 times 2x plus 1. Okay, so this whole fraction has been factored out on the left-hand side like that. Okay, now the point of doing this so that you can identify all the critical numbers. Basically, the thing on the left side here can be positive or negative, or could be 0, or could be undefined depending on x value. So the next thing we want to do is find those critical numbers. Critical numbers meaning what are the numbers that you can plug in for x that will cause that fraction to be 0 or undefined? Well, for this particular example, the critical numbers are positive, -2, and -1/2. Okay, so what are those three numbers? Well, if you plug in positive 2, notice it'll make that second factor on the top right equals 0, which makes the whole thing 0. If you plug in -2, that'll make that first factor equal 0. And if you plug in -1/2 into x, that will make the bottom right factor equal 0, which causes undefinedness. So these are your critical numbers that cause this fraction to equal 0 or undefined. The next thing you want to do is draw a number line using your critical numbers, because basically they chop your number line into pieces. Okay, at these particular three locations, at -2, your function is 0. At the locations 0, your function is undefined. And at the x equals positive 2, your function is 0 also. So that's why I draw it this way here. Okay. So those are the places where your fraction equals 0 undefined, which means everywhere else on this number line, it's either positive or negative. Okay. So once you map out what the fraction is, whether it's positive, negative, 0, undefined, across the number line, then you'll know how to answer this question. Okay, but here comes the next part. You need to figure out what each region the sign is, whether it's positive or negative. And that requires you to plug in numbers. So what is a number left of -2? -3. So that's a good test number. You test out -3, which is shown here on the top of the page here. I plug in -3 into x, and these are all the numbers that are being plugged in. And if you evaluate that, and we're not really concerned about what the number is. Okay, so that first factor, -3 plus 2, notice that's basically -1. So that's going to be a negative number. Okay, again, we're not concerned about the actual value. And the second factor is also negative, because -3 minus 2 is -5. And on the bottom, what is that sign? Is it positive or negative? It's negative. So you got a negative times negative divided by negative. So overall sign is negative. And that's why on the number line, I mark that region as negative. Then you repeat the cycle one more time. What's a number between -2 and 0? Well, I picked -1, which is between those two numbers. So -1 plus 2 times -1 minus 2 on top. And on the bottom, you still have that 3, and then times 2 times -1, which is basically -2, plus 1. Again, we're not concerned about the value. We're concerned what is the sign of that fraction. Is it positive or negative? Well, that first factor on top is negative. I'm sorry, it's positive. And the second factor is negative. And the factor on the bottom should be negative also. So you got a positive times negative divided by negative, which means the overall sign is positive. And that's what we mark on the number line there between -2 and 0. So let's do this for the last two pieces. Okay, between 0 and 2, well, I'm sorry, between -1/2 and 2 is 0. So 0 is the obvious choice to plug in, and that's why I did there on top of the screen there. Again, figure out the sign. You have positive for the first factor, a negative for the second factor, and on the bottom factor, you have basically another positive. So positive times negative divided by positive should be overall negative. And that's why I'm marking the number line there as negative sign. Okay, and of course the last piece is from 2 all the way up to positive infinity. What's a number to plug in? Well, 3 is a good choice here. So 3 plus 2 times 3 minus 2 all over 3 times 2 times 3 plus 1, which is the same thing as 6 plus 1. And what's the sign of that? Well, the first factor should be positive. The second factor should be positive also. And the bottom, it's a positive factor. So positive times positive divided by positive. Overall is positive. And that's what I have here on the number line. It's completely mapped out now. Negative, positive piece. Of course, your critical numbers are where the function equals 0 or undefined. So reading off this number line, what caused this factored out fraction to be greater than 0 or equal to 0? Well, reading off of that, x should be in the interval that corresponds to the positive sign. So that's from -2 to 0, and then from 2 to positive infinity. Now, whether you include the endpoints or not depends on if your fraction equals 0 or undefined at those endpoints. And that's why at -2 is a bracket, And then negative 1/2, it's a parentheses because the function is undefined there. Okay, sorry, I don't know why my video paused there. And then the second interval where it's positive is from 2 to infinity. Do we include 2? Yes, we do, because it's part of this greater than or equal to. And of course, you use parentheses for the infinity sign. So the domain for this particular function is a merge of two intervals, from negative 2 to negative 1/2 and from 2 to infinity. Okay, so before we quit, I just want to remind everyone the basic question that we should always ask when we come across a problem, whether it's easy or complicated or not. Always keep in mind there's two things to watch out for, whether you have a 0 in the denominator or in the numerator. Of course, in the denominator it's not allowed, in the numerator it is, or whether you have a negative radicand or not. Okay, that if you have 0 in the bottom, then that's a no-no. If you have a negative number in the radicand, that's a no-no. Okay, those are the things that you constantly need to focus on, unless you're dealing with the rational radicand that in our last example. There, it's a special problem. So, if you need to, rewind back to that part of the segment and just review it as many times as it takes. Okay, before we close, I just want to go over 3 things that may trip up people on quiz and test days. So please keep these in mind so that you can make the highest possible grade you can. That is, if you have a 0 in the numerator, remember, it's okay. Don't try to solve for it and say, this shouldn't be here and all that. It's okay to have 0 on top, so leave that alone. And if you have a square root in the denominator rather than the numerator, then you need to amend your inequality from greater than or equal to just strictly greater than 0. Okay, and that was shown in our example problem 1 earlier. And the third point I want to make is that if you have a fraction as a radicand, then you need to treat that fraction as one whole piece. That radicand must be greater than or equal to 0. And from there, you factor it down, you break out into several pieces on the number line, and you figure out what the sign is, positive and negative. And for those critical numbers, they identify where your function is 0 or undefined. And from there, you can read off your number line, your answers, which is usually a combination or merge of intervals. That's it.